So when you have a problem, okay, like 3A and 3B, you want to look at this when you have a trinomial like this, okay? You want to look at this and go, maybe this is quadratic in nature, okay? And what I mean by that is it is not a quadratic, okay? It is not a quadratic, but can I rewrite it? And this is like the video I posted on Friday that I wanted you guys to look at so you came in ready to kind of see these problems. So what you're looking at is going, hey, can I end up getting this to be like, like basically an ax squared plus bx plus c equals 0 type of a problem? Can I make it look like this? Now, when you are doing this, what you want to notice about a quadratic, ignoring the coefficients in front of your x squared and your x, this x, if I square that variable, I get this. That is quadratic in nature if I can get a situation like that. So what I'm looking at here is I'm looking at this x to the 1/3 compared with this x to the 2/3. First off, just to make sure everyone understands, if I have something raised to the 1/3, just so you know this or remember this from integrated 2, this is really a cube root. That is really a cube root, just so everyone understands that. When I raise something to the 1/3, that is really a cube root. When I raise x to the 2/3, what I'm really doing is I'm taking the cube root of either x squared or the cube root of x, and I am squaring that. So just so you understand what an x to the 1/3 means in terms of as an exponent, any fractional exponent is a root. Okay, the numerator is the power you're raising, the denominator is the root you're taking. Something else to remember, if you have x to the a raised to the power b, laws of exponents, okay, let me just kind of zoom in here for a sec. Laws of exponents, you are going to multiply those two things together. That's something else I want to kind of think about here. So when I notice that I have an x to the 1/3 and I have an x to the 2/3, again, x to the 1/3 is a cube root of x. X to the 2/3 is a cube root of x squared. There's my square. So what I'm going to do is I am going to let, our book uses u, so I'm going to use u. You can use whatever variable you want, but do not use x because our equation has an x, okay? Use any other variable you want. So I'm going to let u equal x to the 1/3. I'm going to have it equal this without the coefficient. Now, what I'm going to do is I'm going to take that u equal x to the 1/3, and I am going to square this side and square this side. Well, when I square, and I'm going to zoom in a little bit more, okay, just so we can kind of see this. When I square an x to the 1/3, power to power, I multiply. And I am going to get x to the 2/3. And that is this. So this is going to be quadratic in nature, where my first one, the x to the 2/3, I'm going to rewrite as a 2u squared. My negative 9x to the 1/3, I'm going to rewrite as a 9u. So for this, again, my u is going to represent x to the 1/3. When I square u, I get u squared. When I square the other side, I get x to the 2/3. So again, I'm going to rewrite this as 2u squared, because x to the 2/3 is a u squared. And then minus 9u, because that's what I decided to have u represent, x to the 1/3, minus 5 equals 0. Now I have a quadratic. Okay, and this is why I'm saying it's quadratic in nature. It's not a quadratic in the sense that this is an x squared problem. It's an x to the 2/3 and an x with an x to the 1/3, but I can rewrite it as a quadratic. Again, our goal is to, when you see some variable to a power in a trinomial with that same variable to a different power, you're hoping right now in these problems that you can get it to be a quadratic down the road. Okay. So you take whatever is in the middle term. You have that equal u, which I had right here. Okay. I said u equal x to the 1/3. I'm going to zoom in. Okay. Then what am I going to do? I'm going to square both sides. So I'm going to take this middle term, this x to the 1/3. I'm going to have it be u. I am going to square this side and I get a u squared. I'm going to square this. So when I take x to the 1/3 and I square it, power to power, I multiply. So this right here is the same as my u, but squared. So then I'm going to rewrite this as 2u squared minus 9u minus 5 equals 0. And I'm going to solve this quadratic. Okay. So let me get rid of this line for a sec. So now if I'm solving this quadratic, this is one that's going to be a, I'm hoping it's going to be factorable. That's what I'm hoping. Okay. So I'm going to try to do a box to diamond. Okay. And this is where we need to understand how to factor quadratics. And hopefully everyone's writing this down on their paper. Hopefully they have their paper. If not, raise your hand and I'll give you the paper. So this is, I'm going to put the 2u squared here. I'm going to put the minus 5 here, diagonal from each other. Okay. If I multiply those together, I get a negative 10u squared. What we learned in integrated 2 last year was that if I was multiplying those together and I got that negative 2u squared, what always happened, the pattern was the other diagonal also multiplied to a negative 10u squared every time. In every problem, those two things ended up being the same. But those two also have to add to my negative 9u. That's why I'm going to put my negative 9u at the bottom. Okay, that's why this works. Okay, so now when I'm trying to figure out what multiplies to a negative 10u squared and adds to a negative 9u, the one that most of us forget is 10 and 1. 10 and 1. 2 and 5, but that's not going to give me a 9. Okay, and since this is negative 10 on top, I'm going to move it up a little. Since this is a negative 10 on top, we are going to be basically really having two different signs that they're going to subtract to get us that 9. So I'm going to have a negative 10u and a positive u. So it doesn't matter which box I put it in. Let's say I put my negative 10u here and my positive u here. And let me just take out those other pieces right now. My goal is to find the outside. When you do this, you always want to start with that 2u squared. That's where you want to start. How do I get that 2u squared? Well, it's going to be a 2u and a u. The way I have mine set up, my 2u has to go there. My u is going to go here. And then I'm going to work the rest out. So then I'm like, okay, 2u times what gets me a negative 2u? Negative 5. I'm u times what gets me a u? A positive 1. So that is now going to be my factors. So I am going to have a 2u plus 1 times a u minus 5 equals 0. That's what I'm solving. I factored it. What we do is we use the zero product property, because if I have two things multiplying together and I get 0, either this first parenthesis had to be a 0 or the second parenthesis. So I try to figure out what makes them 0. So I usually don't write this out, but I'm literally trying to solve that. What makes that 0? And then I'm doing the same here. What makes that parenthesis 0? So for the first one, I'm going to minus 1 and then divide by 2. So my u would be a negative 1/2. For the second one, I am going to add 5 to both sides, and I'm going to get u is equal to 5. Am I done? I wish, but I'm not, right? Because did I have a u in my problem? My original problem, let me zoom back out, had x to the 2/3 and an x to the 1/3. Do not give me u equal negative 1/2 and u equal 5 as an answer. We got to now find x. So now what you guys are going to do is you guys are going to look where u was equal to x to the 1/3, and you're going to set this to x to the 1/3 because that's what u represented. And I'm going to set this to x to the 1/3, okay? Because of this up here. Because of this right here. Okay, I had set u to be an x to the 1/3. So I'm going to come here and I'm going to rewrite this as x to the 1/3 equals a negative 1/2, and x to the 1/3 is equal to 5. Now, I had spoken earlier and said that x to the 1/3 is the cube root of x. I have that right here. And x to the 2/3 is the cube root of x squared, or the cube root of x being squared. But what I would think of with these problems is I don't want this to be x to the 1/3. I want x. I want it x to the first power, not x to the 1/3 power. So I'm not even going to think of it necessarily as a cube root. You can rewrite it as a cube root. We're going to do the same math. But anytime I have x to a fractional power and I want it to be just x, raise it to the reciprocal. Raise it to the reciprocal. So let me just rewrite my x to the 1/3. And when I say raise it to the reciprocal, what's the reciprocal of 1/3? 3. 3 to the first. The reciprocal of 1/3 is 3/1. Reciprocals are when you flip it. Why am I doing this? Because when you multiply reciprocals together, you get 3/3, which is 1. That's why I'm doing it. That's why I'm doing it. Now, if I do it to one side, I have to do it to the other side. So on this side, I had a negative 1/2. I also need to raise that to the 3rd power. So when I take x to the 1/3, raised to the 3rd power, power to power, I multiply. And the whole reason I did this, the whole reason I raised it to the reciprocal was to get a 1. So at this point, I have x. On the other side, I'm going to cube a negative 1/2. When you cube a fraction or raise any fraction to a power, you raise the top to that power and you raise the bottom to that power. So a negative 1 raised to the 3rd is negative 1. A 2 raised to the 3rd is 8. So that is going to be one of our answers. Okay. Now, let me just move this x to the other part. It was, so I had two things here. I set this to this, and then my u equal 5 is also an x to the 1/3 equals 5. And so let me just make that look like a 1/3 exponent. And so I'm going to go through the same process. I don't want that to be an x to the 1/3. So I am going to raise this Let me rewrite it one more time so you see what it is. Okay, I'm going to raise this side to the power 3. I'm going to raise this side to the power 3. Power to power, I multiply. And again, the whole reason I took 1/3 to the third is because 1/3 times 3 is a 1. The reciprocals, when they multiply, are going to become a 1. So this whole thing here becomes x. And then 5 to the third is a 125. And those are my two answers. So I want you guys to do the one next to it, and then we're going to talk. So for this, I'm hoping that when you see x to two different powers in the same problem, maybe it's quadratic in nature. Okay, that's what we're looking at. So what I'm thinking is, okay, this one here, I'm going to have u equal that. So I'm going to let u equal x to the 1/2. Now, x to the 1/2, let me write it so it looks like it's an exponent. X to the 1/2 is really the square root of x. So I'm just going to make a little note that x to the 1/2 is really the square root of x. That's really what that means. Okay, now I'm going to square both sides. So I'm going to have u, and I'm going to have the x to the 1/2. I'm going to square this side, and I'm going to square this side. When I do that, I get u squared is equal to power I multiply, and I get an x. So hopefully now you see that this x is going to become that u squared. And this x to the 1/2 is going to become our u. So I'm going to rewrite this as u squared, okay, because that's what x is. It is u squared minus 2u, because u, I decided to have it be x to the 1/2, minus 3 equals 0. Now I have a basic problem to factor. I'm just going to do a diamond. I honestly think the diamond, but I'm going to draw it here. What multiplies to -3 and adds to -2? That's going to be a -3 and a 1. So this is going to be a u minus 3 and a u plus 1 equals 0. This is going to be u equal 3. This is going to be u equal -1. Don't circle those answers because the original problem had no u in it. So we need to find our x. So remember, we set u equal to x squared. So in place of these u's, not x squared, sorry, x to the 1/2, we're going to put in x to the 1/2. So I'm going to rewrite this. So I'm going to go x to the 1/2 equals 3. That's for this one. And this one here, I'm going to do x to the 1/2 equals -1. Now, remember that x to the 1/2 is the same as the square root of x. And remember that when I had square root of x, this was equal to the principal root. And the principal root is positive. So when I have this x to the 1/2, that is also has to be a positive because it's really the same thing. So why am I saying that? Because right here, it's equal to a negative. So this one here, no solution. That's not going to be part of my answer. Okay, that one's I don't even have to deal with. Now, for the other one, okay, let me just move this a little bit. How do I undo x to the 1/2? Well, again, if you're trying to get rid of an exponent, raise it to the reciprocal of that. So I'm going to raise this to the power 2. And I'm going to rewrite it so that I have the original problem here for people. Okay, so this was x to the 1/2 equals 3. So I'm going to raise this to the power 2, which means I'm going to raise this to the power 2. And when I take x to the 1/2 raised to the reciprocal, I should get x. That's the whole reason I'm doing it. So I'm going to get x. On the other side, 3 squared is 9. That's your answer. That's your answer. And a lot of us actually got both of them, squared this one and got a 1. But if you were to plug that back in, you'd see that that one didn't give you an answer. Something we're going to be learning is when you have an x versus an x squared, you're going to be generally getting one answer. Okay. So what you want to notice on these problems is if you notice that you have the same thing in more than one spot, that's what you're going to want to have your U be. I'm not looking at the square in the first outside the first parenthesis. I'm looking at what's in the parenthesis. Both of them have an x minus 1. So I am going to let U equal x minus 1. And you want to write out what you're having U represent. So I'm going to let U equal x minus 1. And if U equals x minus 1, and I take U and x minus 1, I square this side and I square this side, you see that the x minus 1 squared, that's going to be my U squared. So I'm going to rewrite this problem 1 over U squared minus 1 over U minus 2 equals 0. That's how I'm going to rewrite this. So at this point, what do I want to do? What do I want to do at this point? Fraction bust. Let's fraction bust. Okay, let's fraction bust first. So I'm going to fraction bust. Okay, fraction bust. What am I going to multiply everything by? Okay, will a U get rid of U squared? I'm going to do U squared. So I'm going to multiply everything by U squared. So I'm just going to rewrite the problem so that we see it here. Okay, I'm going to multiply everything by U squared, everything by U squared, everything by U squared, everything by U squared. Even my non-fractions, every term has to be multiplied by U squared. Now, when I did this, and I'm just going to rewrite this, give myself a little space. I don't know why I wrote it like that. Okay, here. When I write this, notice I'm writing it in the numerator. Some of us like to sometimes write it in the denominator. I think we're just trying to squeeze it in, but it's not in the denominator. Okay, it's in the numerator. It's going to cancel out with the denominator. So at this point, this U squared is going to cancel with this U squared, and I'm left with 1. I like that. In the next part, this U is going to cancel this U squared, and I'm just going to be left with U. Do we agree? So that's going to be minus U. Or if you want to cancel the square, you can cancel the square. Okay. Then I have a 2U squared, not doing anything with that because nothing's going to cancel. There was no denominator. And then 0 times U squared is 0. Now I have a quadratic. When you have a quadratic, couple things. You want it to equal 0, and I do not like my x squared or U squared, whatever my variable is squared, to be negative. I like it to be positive. So there's one of two things I could do. I could multiply everything by a -1, And then that would make this become a positive. Or I could really subtract 1, add u, add 2u squared to the other side and make it positive that way. Both of them are going to result in the same thing. Okay. So a lot of times what I'll do is, again, you can multiply by a -1, but I'm going to go, okay, I want 0. I want 0 on this side. Okay. What do? Well, I'm going to add the 2u squared. I'm going to add the u. I am going to minus the 1, or make everything opposite. Okay, or make everything opposite. But you want your quadratics to equal 0. You want your x squared, or in this case, u squared, to be positive. So whatever side's going to make it positive, take it to that side and bring everything else with it. Okay, so now we're going to solve this. And I am going to do a box to diamond. So I'm going to have my 2u squared and my -1. Okay. I multiply those together. I get a -2u squared. It has to add to that plus u. This plus u has to add to this plus u. So that's going to be a 2u and a -u. I'm going to put my 2u here. I'll put my -u here. It doesn't matter. But once I do it, I'm going to kind of set where things should be. And I always focus on this u squared. How can I get that 2u squared? Well, I can get it by taking a 2u. See, I was going to write it in a different color so we could see it. A 2u times a u. And then 2u times what gets us 2u? Well, that will be a +1. And u times what gets me a -u? -1. So I'm going to get 2u minus 1 times u plus 1 equals 0. And we're going to solve this quadratic, okay, situation. I'm going to use the 0 product property, which means I'm going to set both parentheses to 0. So I'm going to write it out. But if you can just in your head go, okay, I'm going to add 1, divide by 2, give me the 1/2. You don't have to write that out. Okay, I don't write that out. And then this one, again, I'm taking this and setting it equal to 0, and that's going to be a -1. So when we are trying to finish this problem, okay, we have the u is equal to 1/2 and the u is equal to -1, and we need to find x because our original problem had an x in it and not a u. So at the beginning of this problem, I defined u to be x minus 1 right here. So let me just highlight this. So up here, this is what my u is. It is an x minus 1. So in place of this u and this u, I'm going to write x minus 1. So let me just do that. So one of these problems, this one here, I'm going to rewrite that one. Instead of it being u equals 1/2, I am going to go x minus 1 equals 1/2, and I'm going to solve. I'm going to add 1 to both sides, and I get 1 and 1/2. Just leave it as that number. That's okay. Let me make this 1/2 a little better. Then I'm going to take this one and also in place of the u write x minus 1 and then equals -1. I'm going to add 1 to both sides and I get 0. Now I did box these answers, but I really should check because anytime you have an x or a variable in your denominator, you cannot get 0 in the denominator. Okay, so if I put my 1/2 or 1 and 1/2 in here, this is not going to become a 0, so that's acceptable. Same here. Over here, I have 0, but when I put 0 in here, I get a -1. Here, I get a -1 being squared. That's acceptable. So one answer is going to be x equal 1/2. The other answer is x equal 0. So now try number 4B. And something to notice here is that in both of these parentheses, I have an x squared minus x in this parenthesis, and I have an x squared minus x in that parenthesis. So that is what I'm going to let u equal. So pause the video, try the problem, and then come back and see how you did. Okay, so I am going to let u equal x squared minus x, okay? So that means right here, that is going to be my u. Over here, this is going to be a u squared. So I'm going to rewrite this as a u squared minus 8u plus 12 equals 0. So again, in place of this, I'm writing u. In place of this, I'm writing u. So now I'm going to solve this, and this is just going to be a diamond. So what multiplies to a positive 12 and adds to a negative 8? So that's going to be a negative 6 and a negative 2. So I'm going to get a u minus 6 and a u minus 2 equals 0. I'm going to set each of these to 0. The first one, my u would be 6. Second one, my u would be 2. But again, my original problem had no u. It had x's. So remember, u was representing, okay, let me get rid of this here. So u was representing x squared minus x. So in place of this u here, I'm going to write x squared minus x. And in place of this u here, I'm going to write x squared minus x. So I am going to have x squared minus x is equal to 6. That's going to be one equation. And I'm going to have another equation, which is going to be x squared minus x is equal to 2. I ended up with another quadratic. Okay, two more quadratics. So when we have a quadratic, we want them to equal 0. So I do not want a 6 here. I'm going to minus 6 here. So I'm going to get x squared minus x minus 6 equals 0. And I have another diamond. Okay, what multiplies to negative 6 and adds to negative 1? Well, that's going to be a negative 3 and a 2. So this is going to be an x minus 3 and an x minus, plus 2 is equal to 0. So now when I solve this, this parenthesis, let me get the problem back in here. This parenthesis is going to give me x equal 3. This parenthesis is going to give me x equal negative 2. I still have the purple equation to solve. So for this one also, I am going to try to get rid of this 2. So I'm going to minus 2 from both sides, and I get x squared minus x minus 2 equals 0. Again, I have another diamond. What multiplies to negative 2 and adds to negative 1? So that's going to be negative 2 and negative 1, and that's going to be a negative 2 and a positive 1. So I'm going to get an x minus 2 and an x plus 1 equals 0. This parenthesis is going to be x equal 2 when I solve. This parenthesis is going to be x equal negative 1. And so I actually have 4 answers. I have 4 answers. And when you have an x squared raised to the power 2, power to power I'd multiply, this would end up being an x to the 4th problem. And 4th degree polynomials have 1, 2, 3, 4 answers possibly. Sometimes we get duplicates. In this case, all 4 of them are different. And that's your answer.